So I think this is a really cool section in calculus because it kind of gives a bit of a reality check to the whole thing. It's not just algebra. There's actually a really real life application to this section and really valuable in terms of the great world out there. So yeah, so this section over here we're going to I think we're going to enjoy because there's a lot of practical application. However, that being said, before we dive straight into examples, there's quite a lot of theory we want to just make sure we are clear on. So that's what we're going to do in this video. Okay, let's refer to a cubic graph to start off with, okay? As you can see on your screen, I've got myself a cubic function, and you can see that I've identified both the stationary points, the maximum one and the minimum one, and your blue arrows are pointing to them. Do you see that I have labeled the top turning point your local maximum and your minimum and your other turning point the local minimum? Okay, why local and max, local minimum? So the reason for that is because this turning point over here, it is your maximum turning point, but because this side over here is going to continue getting higher and higher, it's not the maximum y value in the graph, it's just your maximum turning point. Okay, so your local maximum is over here, and similarly, because these y values are going to continue just getting lower and lower, this turning point is not your minimum value of the graph, but it's the minimum turning point, so it's your local minimum. Okay, now we learned with cubic functions that if you are wanting to work out the gradient of a tangent, so if I were to draw a tangent for you at that turning point over there, and I were to draw another tangent for you at that turning point over there, what can we say about the gradients of the tangents? All right, so we have covered this when we worked with cubic graphs, but basically we know that the gradients of the two tangents are absolutely flat, so therefore there's no rate of change, so the derivative is equal to 0, and that's the case for both the maximum turning point and the minimum turning point. The derivative is equal to 0. Okay, so that's fundamentally the principle that we're going to be working on when we're applying this kind of concept to more real life applications. Okay, so what I want you to remember at this stage is that when we're trying to work out a maximum or a minimum point, we let the derivative equal to 0. Okay, now we're going to put that aside for a second, and we are going to take a minute to just do some revision on some formulas, particularly your area, your volume, and your surface area formulas. Why? Because very often the application questions in this section are about calculating maximum area or minimum volume or maximum surface area, all of which require you to have a pretty good grasp on your formulas. Okay, all right, so shooting through these, we won't take too long, but let's just quickly go through them. Right, area of a, sorry, let's get rid of that, I'm looking for my screen. Right, the area of a square. Right, we know that a square has all four sides that are equal in length. So if I've got side, 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 and side, the area is essentially length times breadth, side times side, and that's going to give you your area. So if you want to write side squared, okay, that's fine. And then obviously because it's area, it's units, whatever the unit of measurement is that you are working with, meters, centimeters, and those units have to be squared. A rectangle, all right, so again, you've got your length, we've got our breadth, okay, and to find the area of our rectangle, length times by breadth, which will equal your units squared as an area. Circles, all right, the area of a circle we calculate by taking pi, the value of pi, times by the radius. What's the radius? It is the line from the center of your graph, from the center to the circumference, okay? So remember, the radius doesn't matter where you're taking it from the center to the circumference, the length of your radius is always the same. And the area formula will be area equals pi times your radius squared. Okay, I'm sure we remember that from years gone by, but that's your formula for circle. Triangle. All right, to work out the area of a triangle, we have got half of the base. This over here is your base multiplied by, now when I talk about the height, I'm talking about the perpendicular height. So from the apex of your triangle straight down to the base. So multiplied by the perpendicular height. Okay, so I'm hoping there are no surprises there that you see. I'm sure that you recognize all of those formulas. Now let's take a minute to go through some volume formulas. Okay, the concept of volume is obviously you've got a three-dimensional figure, and volume is essentially how much space is inside that shape. All right, how do we calculate the volume? All right, well, let's start with a cubic prism or a rectangular prism, and we're going to start with this. To work out your volume, you want to start by calculating the area of the base of your shape. Okay, so for the volume, we're going to start with the area of the base. Now in this case, I've got a length and I've got a breadth. So we're going to take the length times by the breadth. Okay, and then once you've worked out the area of the base, you're going to multiply it by the height of the shape. Because essentially what you've done now is you're taking all this area at the bottom and you're extending it up the sides of your shape to essentially give you all that space inside it. So length times breadth times height, this being your height over here, will give you, we don't actually need that bracket, so let's take it away. That will give you the area, the volume of your rectangular prism. All right, area of the base times by the height. If I followed that similar theory with a cylindrical shape, okay, if I took the area of the base, okay, now obviously it's just the shape that's changed. So for the volume of a cylinder, I'm taking the area of the base where that is a circle, so it's going to be pi times by radius squared. And we multiply it by the height of your shape. So how much height have you given to that shape to create that space inside? So pi r squared times by the height will give you again the volume of that cylinder. A triangular prism, well, if we followed the same concept, okay, now be careful with a triangular prism. The base shape of a triangular prism is not this rectangular base that it's lying on. The triangle itself is the shape that's actually creating the triangular prism. So when you talk about the area of the base, it's actually got to be the triangle part, okay, because that's making it a triangular prism, all right? So the area of the base, okay, which means I need to take this base times by this perpendicular height, all right, is going to be half base times by the perpendicular height. And then we need to multiply it by the height of the prism, or maybe you want to consider it the depth of the prism. That over there is going to tell you how deep the prism is, and that will give you the volume. Sorry, again, we really don't need that bracket there, so let's take it away. All right, so can you see that for every single one of those prisms, each one of them, the way I worked out the volume is I found the area of the base and I multiplied it by the height, okay? So you just need to remember that formula in general, and then you don't need to learn every single individual formula. You can just apply you can kind of make each one fit as you're going. So volume is equal to the area of the base, and it's multiplied by the height of your shape, okay? And if you can remember that for volume, you should always have the formula that you need, okay? Okay, then surface area. Surface area is always the one that catches everyone out just a little bit more. Surface area as a concept means that we're taking the area of every single external face of your shape, okay? Probably the way you learned how to do surface area right in the beginning is that you were taught to break the shape up into individual faces, and you had to work out the area of each one individually. and then add the whole lot together, okay? Now that's fine, but in terms of the way you want to use this in calculus, you don't want to do it that way, okay? You need to use the formula like I'm going to show you over here in order to actually apply it in calculus, okay? So what do I do to find the surface area of a prism? Well, this is what you're going to start off with doing. You're going to take the area of the base, all right? So to take surface area, we start with the area of the base, which in this case is a length times breadth. So we've got our length times by our breadth. Now, there is an area at the bottom, and the area at the top are exactly the same, all right? So the area, that's actually the kind of nature of a prism, is that the shape at the bottom is identical to the shape at the top, okay? So we're taking the area of the base and we're going to times it by 2 to account for that bottom and that top shape. Then we're going to say plus, all right? Then we're going to do this. We're going to take that same base, but we're going to work out the perimeter. Can you see in red I'm tracing around the perimeter of the base? Okay, perimeter just being the sum of all the sides of your shape. So we're going to take the perimeter of your base, hello, which is going to be your length plus your breadth plus your length plus your breadth, okay? So we've got 2 lengths plus 2 breadths, that's the total perimeter, and you are going to multiply that whole answer by the height of your prism, okay? What that's doing is it's actually in one quick calculation working out the length times the breadth and the length times the breadth and the length times the breadth of all the side faces of your prism, okay? So in one quick calculation, that's going to be your surface area. So what did I do? I took the area of the base times by 2, and then I worked out the perimeter of that base, and I times it by the height. So let's see if we can apply that to a cylinder. We're going to take the area of the base, all right, area of a circle. So this is for surface area. We're going to take pi r squared times by 2. Okay, that's giving us the bottom and it's giving us the top. Then we're going to say plus the perimeter of the base. Now we need to remember the formula that for the perimeter of a circle, and that is 2 pi r. So the perimeter of the base, and again we're multiplying that by the height. That's giving you all this area around this cylindrical, whoops, that took away everything. It gave you the area all the way around the cylinder. Okay, all right, so triangular prism, same story. We start with the area of the base and we times it by 2 to give us the top and the bottom, or the front and the back. So for surface area, we say the area of a triangle, which is half the base, times by the perpendicular height. And just make sure we're understanding that this over here is your perpendicular height, this over here is your base. And we're going to times it by 2 for the back and for the front. Plus, now the perimeter of a triangle, unfortunately there's no special formula I can give you for that. You're literally going to have to add the 3 sides of your triangle up, okay? So don't assume, okay, I'm saying side, side, side here, but you can't assume obviously all 3 sides of the triangle are equal. So whatever the 3 sides of the triangle are, you adding those 3 sides up, and that answer is getting multiplied by this height, okay? Getting multiplied by the height of your prism. And that again will give you your surface area. So in general, what do we do to find the surface area of a prism? To find it, we take the area of the base and we double it because there's a top and a bottom, plus the perimeter of the same base that you worked out the area of, okay, so the perimeter of the base, and we multiply that by the height of your prism, all right? And that will then give you the surface area. Practice those. You do need to know how to put those formulas together so that we can then go on and actually put it into practical examples. All right, so go practice those, and I will see you in the next video where we're going to start doing some examples.